Good evening, everyone. Welcome to another one of our focus sessions. This one's going to be on the urinary system. We only have a few of these left for the semester before we get into our final exam. And then our urinary exam is this week. So I just want to cover some additional topics that I did not cover last week and also do a quick review about what we talked about last week. Biggest thing, we just have 2 weeks left. So really just the end of this week to get through urinary and the exam. And then we'll have about 2 weeks, give or take, for male, female reproductive system. And then the last week is finals. There's no class, just exams. So we're in the thick of it. So I just want to say, um, at this point in the semester, take a look at your grade, um, see where you're at, calculate, how many points you need on your exams and your final assignments to kind of figure out where you're going to end up on the grading scale. If you have your any redos or any of those tokens left, I would use them. You don't get any points for saving your redos. So if you have a few left, I would definitely use them to retake your exams. Or if you've done really well on your exams, use them on some of your assignments. Just try to maximize your points, especially if you're one of those students that's on the edge. 5 points here, 10 points here, 20 points here could really help you push that grade up, an extra letter grade. I've seen it too many times this semester where we finish up get to the end and some people are sitting at 89% or 79% or 68% and really just a couple 5, 10 points here would have pushed them up to the next letter grade. So don't let that happen to you. Review your grades, see what you can do. Um, and then, again, don't go into the final exam stressed because you needed to pass. Try to get those points down now with the next three exams and the next few assignments. So you give yourself some buffer before we get to the final. I'll also talk a little bit about the nephron, just kind of review the things we talked about last week, and then go over some key terms and concepts that I've seen students struggle with for this chapter. So again, quick review for the nephron. Again, it is our most important part of the kidney. It does a majority of the work that the kidney is designed to do, which is to filter out our system, our blood. So the basic flow is blood will flow in through the afferent arteriole. It'll then get filtered um, through the glomerulus into the Bowman's capsule. This whole this ball, this glomerulus and Bowman's capsule are considered one unit called the renal corpuscle, and then the rest of it is the tubule sections where the waste products that come out of your glomerulus, combination of water, plasma, also some electrolytes, and some other like amino acids, things like that. Make its way through the tubular elements, starting with the proximal tubule, then down the loop of Henle, out the distal tubule, and out through the collecting duct. And then to remember that the nephron is composed of the renal corpuscle and also the tubules, not to include the collecting duct. The collecting duct will get flow from many different nephrons, and that'll feed back out of your kidney into the urinary system and then out of the body. One big thing that you will be tested on, and I highly recommend you study, is the difference between reabsorption and secretion. So again, part of the urinary system and the nephron in general is to reabsorb things in the body that we did not want to get rid of. The big ones for these are obviously electrolytes in water, things like sodium, potassium, um, chloride, that kind of thing. Um, Water gets reabsorbed, and like I mentioned last week, glucose, 100% conservation of glucose. So we will always save glucose. That happens in the nephron. And the other thing is secretion. So stuff in our blood will be secreted into the nephron to then get combined with our waste to then get removed from the body. Things that get removed from our body are things like um, hydrogens, ammonium, urea, also antibiotics and drugs are removed from our body through the nephron. Remember that there are different hormones that act on the nephron, but the big three that I highlighted last week are ADH, aldosterone, and parathyroid hormone. These all act in different ways. ADH obviously is there to help us conserve water. That acts on the collecting duct. And then the aldosterone allows us to conserve sodium and potassium, while parathyroid hormone allows us to conserve uh, oh, I said calcium. Sorry. Aldosterone helps with sodium and potassium. Parathyroid hormone helps with calcium. Those are some of the big hormones. There are some other hormones listed in your notes, but these are the big three that go back to Unit 1 on endocrine. And if we were to do a cumulative final, these are three of the hormones that I would really highlight because I can talk about the endocrine system in Chapter 1 and also apply it here to urinary in this chapter. If you have more questions on this, I talked about a little bit more about this in the previous video for the nephron. Okay, only a couple different things to talk about. If you probably noticed that the urinary system is not that complex, not that deep, not a lot of notes on it, but there are some key terms and concepts that students do struggle with that I see every single year. And one of them is the glomerular filtration rate, or GFR. So when I was a student, I remember being asked a couple different questions on this, and if I recall properly, I did not get these right. It seems pretty basic as a term, right? Filtration rate is how much filtrate you make per minute, but the regulation of GFR is something that I struggled with as a student, and if I could put money on it, I would expect at least a couple questions on this during the exam. So the big thing to highlight here is that depending on whether you're a male, a biological male or female, you'll either make 150 to 180 liters per day, but you only excrete 1 to 2 liters per day. That means that majority of your filtrate, which is predominantly made of water and other things, but primarily water, is typically reabsorbed into the body. So our kidneys are working really hard um, to filter our blood of any contaminants. But at the end of the day, most of the water in the blood that makes it through the glomerulus into the loop typically gets recirculated, and we can basically have fresh or recently cleaned water go back into our system. And we really only get rid of 1 to 2 liters per day of water. One of the concepts that you might be asked on the exam, I do expect it, is what kind of conditions will change your glomerular filtration rate? These are the three that are mentioned in the notes. They don't really tell you um, what they'll do. They kind of do, but they really don't if you're not, if you don't understand the concept. So I kind of want to discuss those here. That way it stands out a little bit more for you during the exam. So the first one we talk about is the myogenic mechanism, or autoregulation, or local. These can be phrased in any of the ways I just said. Myogenic mechanism is also autoregulation, which is also local control. Myogenic mechanism is basically a property of smooth muscle where it'll expand or contract depending on any changes in blood pressure. You kind of know that smooth muscle is involuntary. Essentially, the smooth muscle will try to counteract the pressure changes to keep pressure stable in a local area. So in this example, it talks about the afferent arteriole expands. So if I have an increase of blood pressure um, in my body, that blood pressure will be felt by the afferent arteriole. It'll expand, which is, the main artery coming in. The artery will try to expand because of that blood pressure, but because of the myogenic mechanism, the smooth muscle around the area will actually constrict, and that maintains pressure constant. And glomerular filtration rate is dependent on the pressure in the area. So how much pressure is pushing the fluid, the blood, trying to get that fluid to go through the glomerulus to get filtered out. So if you do have an increase in blood pressure, the smooth muscle will still um, counteract it. And ultimately, you don't change your filtration rate. So that 150 to 180 per day that you are making, even if you have a increase in blood pressure, like in the short term, your pressure is going to remain the same in the glomerulus, and you're not going to filter out anymore. If I recall in the exam, I made this. This is the one I got wrong because I thought, oh, more blood pressure means more filtration. Uh, in theory, that would work, but because of the myogenic mechanism, the smooth muscle will actually work against the pressure increase to keep pressure constant. The other two, well, I'll talk about the neuronal or the sympathetic nervous system and hormonal. These act more like how you would expect it to think. So the sympathetic nervous system that's involved in our flight or flight response, understanding that when you're in a high stress environment or you're exercising, the urge to use the bathroom is not there. Your body, especially if you're exercising or you're running from something, it's not thinking that, oh, I'm exercising, I'm working out, I'm trying to become fit, I need more water. If anything, it's thinking, I'm running away from a predator, I'm trying to survive. And so what happens to conserve blood pressure because you're losing a lot of water during this process, through sweat and whatnot, is that your afferent arterioles will constrict to reduce the amount of water or blood that goes through the glomerulus, and that allows the blood pressure in the rest of your system to maintain properly to deliver the nutrients to your tissues. The ultimate result of this is that the glomerular filtration rate will drop when you have a fight or flight response. Things like high stress or exercise will cause a decrease in glomerular filtration rate. If you think about it again, that makes sense. If you think about it when you've exercised, you don't really want to urinate or use the bathroom at that time. But sometimes after you've exercised and you've had a lot of water, that's when you start feeling the more relaxed phase, the rest and digest system, and all of a sudden now you feel like, okay, now I can use the bathroom. And then you have hormonal control. We talk about the RAS, again, going back to the endocrine unit. I think there's also part of cardiovascular, the RAAS or the renin-angiotensin-aldosterone system. And this is a complex system of hormones that work together to help maintain your blood pressure. Um, in this scenario, you have a low blood pressure condition. Let's say you're increased elevation or you're dehydrated, whatever it might be. This will activate the RAS system or RAS system um, because your body is worried about con water conservation. Remember, the amount of water that's in your blood and in your blood vessels is what's going to help you maintain blood pressure. And so your efferent arteriole will constrict. So your afferent or your blood coming in will remain the same, but the blood leaving will be lower. And so what ends up happening is that there's less flow going through your glomerulus, and that'll cause your glomerular filtration rate to decrease. Again, you're trying to increase blood pressure, and in order to increase blood pressure, you want to conserve water. And so RAS does a very good job of helping us conserve water. And in this case, we're not going to filter out as much of our blood plasma because we want to retain that water. Like I said, the last two are pretty straightforward. I need to retain water, so I'm going to filter less water. It's really the myogenic mechanism autoregulation that sometimes gets students. Like I said, it got me, was an increase in blood pressure does not necessarily mean you're going to increase the glomerular filtration rate. Okay, and the other two things we're going to talk about very quickly. These are from your notes, but I feel like these get passed over. One is urea. So urea is a waste product that makes its way um, through our tubules. So it goes through the proximal tubule, the loop of Henle, out the distal tube and then into the collecting duct. But urea has a tendency of being able to be reabsorbed, not into the body, but into interstitial space or interstitial fluid. So here in these little areas in between the loops. And what urea does is urea will help with osmolarity or the conservation of water. So because you have more urea in the interstitial space, water will try to balance out the urea and it'll actually be able to leave the loops and then essentially ultimately it helps with water conservation. The big number is it accounts for 40% of the osmolarity in the medulla, which is a pretty big chunk. Majority of the other stuff is things like the electrolytes, primarily sodium. Um, but urea does actually have a very good function, besides being a waste product, in water conservation. And the other concept that I kind of talked about last week is this countercurrent multiplier. And the reason I'm saying it, I want to say it this way, is the question might ask you about the loop of Henle and how it um, helps you conserve water, but you might also see it referred to as the countercurrent multiplier. And so what ends up happening is this big loop is we like to keep the medulla salty. Um, in the medulla, like I mentioned last week, the medulla um, helps with water conservation, especially in the juxtamedullary nephrons. And so what ends up happening here is the descending loop of Henle will allow water to come out, but not salt. So what ends up happening in your loop, inside your loop of Henle, is that water, or you lose water, and because you're losing water but not sodium, the concentration of salt or the concentration of sodium starts increasing rapidly. And then once you get to this point in the ascending loop, the walls essentially allow uh, the sodium to then seep out into the medulla to then reconserve or to try to balance out the water that is out here. So the primary function of the descending loop of Henle is to conserve water, and it does it by sucking out the water in the descending loop, allowing it to go through osmosis. And then on the ascending loop, now the sodium can follow the water, so that by the time you get back up to the distal tubule, your sodium levels are lower than they were during the proximal tubule. But what could happen is if you have a low amount of salt in your loop, salt from the interstitial space might want to go back in to balance out. So a way that our body somehow managed to do this is it maintains this loop salt highly high with a high salt concentration so that at the very end we can get that sodium out of our body or out of the loop of Henle and back into our body. Um, take a look at this. Like I said, I try to describe this as best I can. It's still something that's on at the base level or at the more higher level, I still don't really understand how this countercurrent multiplier functions, like why it does that. Um, but in general, it's there to help us create a much saltier loop of Henle, and then the sodium and the electrolytes will then follow the water at the end of the trail, but not at the beginning of the trail. And at the very end, all this does is help us with water conservation. Okay, that's really all I had for this one. I did especially consider that we had 2 weeks to do this. A majority of the big things I hit last week, I briefly talked over here, and I just wanted to go over some of these last key terms that I've seen students struggle with. Um, Other than that, we only have two other sessions after this. We'll have the reproductive system, male and female. That'll be next week for male and the week after for female. And then we're into the final exam. So if you have any questions on this topic or anything that we've covered before, let me know. Like I said, I'll prepare something for the final exam. And I'll also be sharing all of the videos I've done, anything that I've shared before, give it all out again. That way you have that access to that before the exam in a few weeks, before the final exam in a few weeks. Okay, if you have any questions, please reach out. If not, good luck on your urinary exam.